Good morning everyone. In the previous video, we have studied about the dipole in external uniform electric field. Now in the present video, we will study about the dipole in a non-uniform external electric field. We know that if a field is non-uniform, then it is represented by unparalleled lines, right? So if we want to represent a non-uniform external electric field, we can represent this electric field like this. This is non-uniform, obviously. So if we consider a dipole in this non-uniform electric field, and if we consider this like this, right? And let's say, for example, the point over here is A. This is point B. So according to the figure, the electric field at B is greater than electric field at A, right? And if our dipole is this is minus Q, this is plus Q, right? So what will be the force acting on this dipole? This will be Q into EB, and the force acting on this will be Q into EA along this opposite direction, right? So from here, which force is greater? We know that electric field at B is greater. So force on plus Q charge is greater than the force on minus Q charge. These are not equal. So here there will be a net force on this dipole because F plus Q is greater. So net force will act in the direction of increasing electric field. This side the electric field is more. So net force along the direction of increasing electric field, right? And what about torque? There is some net force acting on this, and in this orientation there will be some torque also acting on this. So torque will also right, and depending on the orientation with respect to the external electric field, the torque may vary at different points. Now let's take another case, that if we have this case when the dipole is like this. This is minus Q and this is plus Q. Now in this case, if we consider this as point B, this as point A, we know that the force on this will be opposite to the electric field. That means this is your electric field. So the force on this will be Q into EB. This will be opposite to it. And force on this will be along, and this will be Q into EA. Now in this figure, we know that EB is greater than EA. So force on minus Q charge is greater than force on plus Q charge. As clear from the figure, there will be the net force on this dipole in a direction of decreasing electric field. So there will be net force because this one is greater. So left side force is greater. So left minus right will give you a net force along the direction of decreasing field. And torque will also act depending on orientation. So here we can mention that torque also acts depending on the orientation. So this makes it clear that in a uniform external electric field, net force is 0 and torque acts depending on the orientation. But in case of non-uniform external electric field, net force will always act, and torque acts depending on the orientation. That's all for now. Thank you.